Alright, so this is lesson 117, Algebra 2, letter symbols for sets and set builder notation. Not going to really go over much on this. It's going to be a pretty quick lesson, but I do want to make you familiar again with set builder notation. You learned it in Algebra 1, but we're going to go over it again. Letter symbols for sets. Not really too terribly interested in you learning what the letter symbols for sets are because, geez, I've just noticed that different books it changes, but one of the things that you'll remember is, remember when I'm writing the set of real numbers, I will make an R that looks like that. If I'm talking about integers, I might make a double line for I. If I'm doing complex numbers, I'll do something like that and then double that part there. I mean, that's pretty much what they're talking about when they're talking about letter symbols for sets. And what I am interested in you knowing is being able to recognize the counting numbers or natural numbers, which are 1, 2, 3, 4, 5, 6, 7. Whole numbers, which starts at 0 and goes 1, 2, 3, 4, 5, 6, 7. Integers are also counting numbers, but it includes all the positives, all the negatives, and 0. And then we get into rational numbers, and rational numbers are pretty much any numbers that can be written as a fraction. Irrational numbers are ones that can't, like pi is an irrational number because it's 3.1415 and it goes on forever into eternity, and irrational numbers have no ending. The fifth root of 3 is also a rational number. Square root of 2 is an irrational number. Real numbers are pretty much any numbers that we have, except for imaginary numbers, which you're familiar with. And once we add imaginary numbers to real numbers, we have what are called, those are called complex numbers. So what we've got here is we've got complex numbers, and then we've got our real numbers, and then we've got our imaginary numbers, and they split up into all these different what is that called, trees. And anyway, you learned those a long time ago, and really not going to go into much detail about it because golly, I made it all the way through calculus without remembering what all those were, so it must not be too terribly important. But the thing I really want to go over is what is called set builder notation. And I think we've gone over this, but let's look at it again. If I'm looking at set builder notation, it's going to look like this. A little parenthesis sign. I may say x and y, meaning the set xy, if you were to graph it on an xy axis. So if you were to have it graphed like this, the x and y are both real numbers, elements of real numbers, such that y is greater than x plus 2 and y is less than negative x. Okay, so maybe they're going to say graph that. Graph the set whose members are ordered pairs of x and y, where x and y are real numbers, such that y is bigger than or greater than x plus 2, and y is less than negative x. Okay? So what we've done in the past is we wrote it like this. Okay? But now we're going to write it like I have up there, which is called set builder notation. So what you're going to do is you're going to rewrite this, whoops, wrong button, this as y equals x plus 2. And because it does not have an equal sign, the graph of this line is going to be dotted. So y equals x plus 2. So we've got like a graph that kind of looks like this, if you were to graph it. you've got your slope of 1, your y-intercept is 2. Okay? So there's that graph. Y is less than negative x. And if you were to graph that, and again it's got a less than sign, so you've got a dotted line, and if you were to graph that, it would go this way. It's got the word and in it, so I need it to be true for both of those. Okay? Y is greater than x plus 2. So these are all the numbers that are greater than the graph x plus 2. And less than negative x. So less than or below this line. Okay, and so it said and, then that means it's going to be, let's go with yellow, let's go with really fat. It's going to be where those intersect, right here, right? That's where both of those intersect. We've done this before, should not be very difficult. The only thing that you're learning that's new is to be able to look at something in set builder notation and graph it based on the set builder notation. And that's it for lesson 117. Not really a whole lot there, and I don't think it's going to give you a whole lot of trouble when you get down up to 16, 17, 18, and 19. You're just doing what we just did right here. So any questions, let me know, and we'll just go from there. And we're going to do some more logarithms in lesson 118. So as I look at the assignment on 117, I don't remember off the top of my head which ones I asked you to do for this lesson. I don't have my website right here handy. So let me at least throw a couple things out at you. I need you to throw out the practice problem, and I need you to look at numbers 16, 17, and 18 and throw those out. The only one that goes along with this lesson that I want you to do is number 19. That's very similar to what we just did. And ignore when it says this. Just don't worry about the squared there. And you will be fine with the rest of them. So just number 19 is the only one you're going to do from lesson 117. The rest of them that say lesson 117, throw those out. In fact, I think I do have you doing 16 through 19. So 16, 17, and 18 throw out. Just do number 19 as part of this lesson. So you should be doing, I think, 6 to 13, and then 19, and then 21 to 23, I think, are all you're doing in this lesson. So anyway, that's it for lesson 117.